Okay, the project editor, simplest way of looking at Revit. You know, I can draw walls, you know, floors, roofs, windows. I can make a building. You know, kind of boring, but actually really pretty amazingly powerful. I've already got a 3D model. Now, let's go back to the plan view. Now, if I click on a wall, I have what are called the properties of the wall. So, you know, so if I were to think of a CAD system, you know, a wall is several lines configured in a certain way, and it doesn't have properties. You know, it has the starting point of the line and the ending point of the line, and not much else. You know, it does have, you know, maybe layer or line style or color, and that's what they call properties in a CAD system. So the properties in a CAD system are related to graphics, drawing. The properties in a BIM system are related to buildings. So, so we see the location line is a wall center line. I could change that, of course. The level, Revit, basically everything is related to levels. So three-dimensional levels. Buildings are essentially a accumulation of levels. How to create levels in space that will stand up and you can walk on and use. You know, base, offset, top, you know, it's and so and so on, so and so. So now you can think of these properties as built-in parameters. They're basically parameters. They can be changed. You know, they're a something with a name, base constraint, and with a set of possible values, and you can change those values. So they're what in computer science we call variables, because the value can vary. So so we have these. You know, I mean, the way to grasp parameters is to just relate them to the properties. They're custom properties that you can create. Now, in the project browser, you know, so or project editor, and I was looking around a little bit, and in the manage menu, you can get at the parameters of the project. Now, first off, there's project information. Now, these are more like the properties. They're built in. You don't get to change them. You know, they're there always. You can't delete them, but they you know, they can have values. So I could put in an owner, you know, Texas A&M, an address, a project name, author, energy settings. So you know, so that's just kind of general information about the project. Everything about the project. It's basically non-graphic for the most part. It's textual information. Now, in project parameters, I can create new parameters. And so I can add a parameter to basically any object. What would be a good one? Rooms are always good. You can add lots of things to rooms. So, so I could add to rooms a public-private classification. So then I could make, I could declare this room's a public room, this room's a private room. And so I can set a text here because I'm going to type in public or private as a value to it. And rooms will vary by instance. And now I can set public and private rooms. So, so just to kind of show that, I'll split this into 2 spaces, and I will put 2 rooms in it. So room 1, we have a public-private parameter now. And I can say this one is public. I can click on this one, say this one is private. So if I go back to this one, you see it's public. This one's private. Now, the room ones are really cool, really powerful. So I've just added a parameter to rooms, and I can do all sorts of things with it. So what I'm going to do with it is I'm going to create a color scheme based on rooms, and it's going to be a I'm going to create a new one, actually. I'm going to call it a public-private diagram. And I'm going to change the color based on public-private. So that parameter I created shows up in here, and I can change the color that way. And it picks 2 colors, one for public and one for private, and colorizes my plan based on the parameters that I created. So amazingly powerful. You could start to generate diagrams automatically of circulation systems, of public-private systems, of servant systems, of hierarchy, most important, least important, somewhat important. You could create a diagram for departments. So say you're doing a hospital, you've got the oncology department, the ER department, the intensive care department, the walk-in clinic. Those could each be colorized on your plan, just like that. And if I change something, the diagram updates immediately. So, so what you should think about this as is you're encoding information into your model. First off, your model is a model of a building. It's not a model of a drawing. It's a real building that you're modeling. A digital representation of your building, a digital twin, they sometimes call it. And you're encoding that information into your building, and whenever you change something in your model, it changes in that information too. And that's what's called parametric modeling in general. Because I changed the length of this wall by simply dragging that. That was a parametric change. Now, okay, so I just added a parameter to a project element. Now, we were adding parameters to families and conceptual masses on Monday, or not really. We were just creating those things. Now, 2 other kinds of parameters. There's shared parameters. which are parameters that can exist in more than one file. So this project parameter, I created it in this file. If I created another file and I wanted the same parameter, I'd have to create it again. But if I create it as a shared parameter, then I can use it in many different files. So that's the notion of sharing. Share it across multiple files. Now the global parameters are brand new. They're very new in Revit. Maybe 2 or 3 years old. But I can create a global parameter. And I can do it pretty much the way we were creating parameters in the conceptual massing tool. I can create a dimension line. And then I have a label up here, and I can create a parameter for it. So let's call it building length. And if I click on this, well, create a dimension for it. Building width. And you see that they show up in my global parameters here. That global parameters dialog. If I change that width, maybe I can do that. It changes in my model. So I can start to drive the design from the parameter values. Now, I didn't really go through it, but you'll notice there's a formula over here. And I can put in a formula for calculating these parameters. So it could be building length divided by 2. And it calculated it for me. And I apply it, and it changes in my model. So for instance, if I wanted to enforce, such as in Greek classical architecture, I wanted to enforce the golden ratio, I could put it into a formula and make it always have the golden ratio. Now, I see this as incredibly significant, really, really important, because we're starting to get your ideas and concepts about architecture embedded in the model, so that, if you decide that the golden ratio is what makes something beautiful, then you can embed it in your designs and ensure that anything you design makes use of the golden ratio. Now, Le Corbusier late in his career believed that the golden ratio was inherent to beauty, and he put it throughout his buildings. That's the system called the modular. So the modular system that Le Corbusier built, makes use of the golden ratio. I just showed you how to embed that in your Revit model if you wanted to. So so those are the notions of project parameters, global parameters, shared parameters. You know, you could say we have massing parameters or conceptual mass parameters. We have family parameters, and so these parameters are just throughout Revit. And now along with that is the notion of a family and a type. And you know, so these notions of type, of building typology, so that there are certain kinds of shapes of buildings, of functions of buildings that that are recurring, you know, as a abstraction. You know, so the one-room schoolhouse is an abstraction, and a specific one-room schoolhouse is what in Revit terms is called an instance. So the one-room schoolhouse is a family in Revit terminology, and then a specific one-room schoolhouse would be an instance of that family. Now, the notion of type enters into that in Revit terminology, is we have the family of one-room schoolhouses, and we have an instance of a one-room schoolhouse. But we might notice that there are a lot of one-room schoolhouses that are 40 feet by 60 feet. And we keep finding ones that are exactly 40 feet by 60 feet. That's a type. So, so the type is something that can be used repeatedly with the same parameter values, or at least some of the values are the same. So now, you know, a lot of you in the class studied with me in sophomore year, and we explored Richard Meyer's houses. You know, Richard Meyer's houses are a family of architecture. You know, there are many different Richard Meyer houses. They are all in many ways the same. They all have an enormous commonality to them. And then, so there are many different, but there are many different instances. So each one of them is different. It could be that there are some of them that are practically identical. And Nancy Al-Lassoff says the Smith house and the Douglas house, although they look kind of different, are really identical in some sense. You know, so that would be a type. Now Frank Lloyd Wright also used this notion of families and types in his designs. So the Usonian houses were explicitly meant to be houses for the middle class and to be built as mass-produced structures. And so there are a set of standard types, and Wright really liked designing families and types, and so there are very few duplications. It seems like everything's an instance, but there are types within Wright's collection of Usonian houses. So variants that are very, very similar, and so arguably they are a type, and then those two actual constructed ones are instances of that type. So the instances tend to be things that are touching the ground, that are real buildings, and the types are an abstraction or a collection of similar instances. And then a family is a little bit broader sense of more potential variation.